So due to this large phase angle, which is in turn due to the capacitor current which leads the voltage, and there exists a large phase angle between the current due to the main winding and the current due to the auxiliary winding, that is the capacitor winding. So there exists a large phase difference between the currents and also the fluxes due to the main and the auxiliary winding, which produces a high starting torque. So an auxiliary winding plays a very vital role in a ceiling fan at the time of starting. An auxiliary winding need not be only a capacitor, it can also be a resistor as well. If you use a resistor, the current due to the resistor would be almost in phase with the voltage, that is, there would be almost in phase to the applied voltage, and hence the current due to the auxiliary resistive winding and the main winding, there exists a phase difference between them, but not as high as due to the capacitor, and it provides a reasonable starting torque. So this is the basic concept of a ceiling fan. That is why it does not rotate with no capacitor in it. That is, to make it more simpler, why a ceiling fan does not rotate if there is no auxiliary winding connected to it. Thank you so much. I think you would like to see the capacitor which I have removed or disconnected from the fan. This is the capacitor which acted as an auxiliary winding all these days for my ceiling fan, and now the fan does not rotate because there is no capacitor in it. So let me show you the effect of double field revolving theory now. As I have explained earlier, that in a double field revolving theory, the two fluxes due to the stator, that is the alternating flux due to the stator, as it has been divided into two components, that is one rotates in the anti-clockwise and the other rotates in the clockwise direction. So both which in turn result in the production